Hello friends, today we shall discuss blending of aggregates, how to mix different sizes of aggregate to get the desired grading. And this is required in all mixed designs. Either you do it for bitmos layer or for base or sub-base layer. There are 2-3 methods of mixing aggregates, but the most commonly used method is graphical method. And I will explain this method with the help of one example. This method is also called Rothfutch method. Let us take one example where you have to design the mix for dense bituminous macadam. And at site, you have 4 aggregates, let us say A, B, C and D. Maybe 25 mm size, 20 mm size, 10 mm and dust. You can also have lime here or cement here if you are adding as a filler. Now these 4 aggregates are to be mixed in a suitable proportioning, suitable ratio to get the final grading which will be in the range as specified in MORTH. So in graphical method what we do, you take a graph paper or you take simply a plain paper and draw a rectangle on this paper. Try not to have very long rectangle. In fact, a square will be perfect. And then on y-axis, you have the normal scale. You will prepare this axis so that the desired grading becomes a straight line. Normally, when you plot the gradation of a aggregate, then this is not a straight line. So we choose this scale in such a manner that this gradation is a straight line. So let us assume that your target is the midpoint of this range. So here it is 100, 95, 83, 68, 46, 35, 14 and 5. Now this is the target grading. So let us say y-axis you divide into 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is 0, this is 20, 40, 60, 80 and 100%. This is percent passing. Now join this diagonal here. Join this diagonal and assume that this diagonal represents this grading, final grading which you are going to obtain. So you decide the size now. 100% passing is 37.5. So this size is 37.5 millimeter. 95% should pass through 26.5 millimeter sieve. So corresponding to 95, you take a point here and this is 26.5. Next size is 19 millimeter and 83. So take 83 here and you drop a perpendicular here. This is the size 19 millimeter. Similarly, you make all sizes on this scale. So corresponding to 68%, you have the size of 13.2. Then 46% is somewhere here. You have a size of 4.75 and so on. Now this is the scale now. On this scale, when you plot this desired grading, it is a straight line. Now on this graph paper, you have x-axis, you have y-axis. Now plot all these sizes A, B, C, D. So let us say A 100% passing 37.5 millimeter. This is the point here. Next is 68.5. So this size is here, 68.5, 68.5, somewhere here. This is the, here. Next is 13.9, let's say 14, corresponding to 19% size, 14%. This is the 14%. And then 0.26 here, 13.2, 0.26%. This is the grading A. It will not be straight line. Join these points. This will not be straight line because we assume that this is the straight line, desired grading. Okay. So this is your aggregate A now. Similarly, you plot aggregate B also. 100% corresponding to 26.5. So this is 100%. It will start from here. Then 80.4. 80.4 is here, somewhere here. 80.4, 19 millimeter, 20.6. Next size is 20.6. Yeah. This is 20.6 and then 0. This is 0. 4.75 millimeter is 0. So these are also to be joined by a straight line. This is B. Now you plot C. 100. 19 millimeter is 100 now. So this is 100. Then 80.4%, sorry, 94.3, that is 13.2 size. So this is here. 94 is here. 94.3. 18.4. 18.4 is here. 18.4 is somewhere here. This is 18.4. 1.26, 2.36, that is 1.26. So this is aggregate C. C. And finally, the dust D, 100% passing 13.2. So this will start from here. Let me take 100, then 89.7, let us say 90, corresponding to this. Here is 90, this size. 90, 77.5, so this is 77.5. This is 77.5. And then 31, 30.8, that is your 30.8. And 6.12. 6.12 here. Here. Join them. This is aggregate D. If you have aggregate E also, you can plot aggregate E also here. You can mix any number of aggregates using this graphical method. Now let me repeat what we have done so far. You have made a scale on x-axis so that the desired grading becomes a straight line, and then on this graph paper you plotted all four aggregates A, B, C, D, join them by straight lines. Now you convert these A, B, C, D curves also into straight lines. So what we do, we draw balance line, what we call the balance line. So balance line is when you have the area, now you draw a line here, let us say I make a line like this dotted line. And idea here is to draw this balance line in such a manner that area on left side and right side is almost same. So area between this line and this line, actual grading, this total area is equal to this area plus this area. That is the balance line. So try to draw a line, dotted line for each aggregate balance line so that the area under this balance line and the gradation is almost similar on both sides. So this is the grading for, let us say, B. And that is your, so this will be the balance line for C. You can draw this area, total area here is equal to this area plus this area. That should be the balance line. And similarly for this one. This is the balance line, let us say. Balance line. Now, What we do in the next step is join this point, that is the end point of D, the starting point of C. Dotted lines now. So join these two lines, this point to this point. Join them. You get this line. And then from this point, you join this green point here, dotted line. This line. From this point to this point, you join these 2 points also. Like this. 4 lines. Now the point where this line will intersect this desired grading, that is basically the share of A in the total proportioning. Share of A. So this is the share of A. And similarly, this point here, this is the share of B. And this is here, that is your share of C. And remaining is D. Remaining is D. So what you get here, that A is 15%, B is also 15%, C is 25%, and D is 45%. That is 45%. From this to this is 25%, 15%, 15%. Because we have drawn it by hand, so you may not get here exactly what basically written here. But when you draw it on a graph paper using a scale and pencil, you will get 15, 15, 25, and 45%. Now, if you are using filler also, because when you have line here, let us say you add one more column here for line. Line will be 100, 100, 100, 100, 100, maybe 100 this also, and then it will be 98.4 and 95.3. Let us assume that is a filler. So when you plot these points here and draw a balanced line, it will not cut this line. That means it is not required. Thus, this aggregate D basically will satisfy the purpose of 75 micron sieve. But if you are using lime or cement, then deduct that 2% from this. So it will be 43% and lime will be 2%. So final proportioning will be 15% A, 15% B, 25% C, 43% D, and 2% lime. Lime or cement, whatever you are using at site. Now when you use these gradation and try to find out what is the final gradation for this mix, you will see that this almost satisfies the condition of midpoint. You can try this and the final grading which you get will be like this, that 37.5 millimeter, it is 100%, at 26.5, it is 95.27, which is very close to the midpoint. At 19 millimeter, it is 82.27, again close to 83. At 13.2, it is 71.7. At 4.75, 45%. At 2.36, it is 35.65. And similarly other two sizes. So that is how you can mix any number of aggregates which are available at site to get the grading for a mix. It can be bituminous concrete, it can be DBM, it can be BM, STBC, or even GSB also. Thank you very much for watching this video. If you have any questions, you can write in the comment box.